All right, we're going to move on to our next unit. This is going to be from chapter 11. So we're going to go through 11.1, which is about similar figures. So let's do some vocabulary first. We're going to be using a ratio throughout this unit. So what is a ratio? That's when you do the comparison of two quantities, okay? And usually a ratio is using the same unit. And so when you compare those, you can write it as A to B or A to B in fraction. A rate is pretty much the same thing, except on this one, it is a comparison of two quantities, but measured in different units. Okay, so still written as A to B or A to B. So we'll write them both ways. So that's a ratio and a rate, and those two are kind of pretty much the same thing. And so going back to rate, when we say different units, you can compare two numbers like, for instance, you could say 2 inches is to 5, I don't know, centimeters. Okay, if you're going to compare something like that, when the ratio, you want to kind of keep it the same one. So you could say 2 inches is to 12 inches. Okay, so you're using the same unit on ratio and different units on rate. Proportion, you've done a proportion before in middle school. And so that's when you compare, or I'm sorry, when you take two ratios or rates and you set them equal to each other. Okay, so when you take two ratios or rates and you set them equal to each other. And so proportions, we're going to solve by cross multiplication. Okay, so that should look familiar from middle school. So for instance, right here, if I have A is to B is equal to C is to D, so this ratio equals this ratio, you're going to cross multiply here. What's A times D? Right there. And then what is B times C? Like that. And then you want to make sure you equal them to each other. Okay? All right. So since this whole unit's about similarity, let's talk about what similar figures are. These are basically polygons that are the same shape but a different size. So same shape, different size. Simple definition. So some things you need to remember on what it takes to be similar, okay? So first thing, whenever you have similar polygons, all of the angles are going to be congruent, okay? Corresponding, that is. Okay, you will also have proportional corresponding side lengths. So everything's going to be proportional. And then lastly, you need to know the symbol, which is basically this little wavy line right here. All right, so 3 main bullets that you need to know on what it takes to be similar. And lastly, dilation. A dilation is very related to similarity. So a dilation is when you have a non-rigid transformation where every image is similar to its pre-image. Okay, so they're similar, and we just talked about what similarity means. So it's usually going to be an enlargement or a reduction, okay, of the pre-image, and it's going to be by a certain scale factor. And so we'll get into that right here on these next couple of examples. Feel free to pause the video if needed to write these definitions down. Okay, so let's go into what a dilation looks like, okay? So in here, we're going to be able to answer what is the scale factor for this image and the ratio, okay, for these figures to the right. So just to kind of, look at this for a second. This is going to be our pre-image that I just highlighted in blue. And then our image, our new one, is going to be this one here that I'm highlighting in pink. All right. So in this particular dilation, this is an enlargement, okay, because it's going from a small triangle to a big triangle, okay? So whenever it's an enlargement, guys, you have to know that the scale factor is going to be greater than 1. So everybody mark the greater than symbol, okay? So it's going to be greater than 1. So the figuring out the scale factor is pretty easy. Okay, so the scale factor, you kind of want to, let me get my highlighter, you kind of want to see how many times bigger it got. And so you want to look at a ratio that's given. So this side is given, and the corresponding side to that 4 is right here, okay? And so how many times bigger did it get? Sometimes you can easily do that in your head. So 4 to 12, okay? So let's talk about that too, because that's a big difference. 4 to 12. 4 to 12 is going to be your ratio, okay? Which reduces to 1 to 3, okay? Now you can also write that as a fraction too, but just so you don't, because in the past I've had students get confused with these two guys right here, scale factor versus ratio. I would leave this as a ratio like this, so 1 to 3. Now the scale factor is simply a number, okay? So let's put that in parentheses. The scale factor is a number, a ratio looks like this, which I know you can write this as a fraction, but I'd rather you just use a colon, okay? So a ratio is from small to big, from the pre-image to the image. And so how many times bigger did it get? It got 3 times bigger. So your scale factor is just simply a number, which is going to be greater than 1, and 3 is greater than 1. And that's it. And so now to figure out the side links, so for x, well, this is an isosceles triangle, so x is going to be easy. That's going to be 12, because if that's 4 to 12, then that's going to be 4 to 12. Okay. And then for z, use that same scale factor. Okay, since the scale factor is 3, this one's 3, so that means this one's going to be 9, because 3 times 3 is 9. Okay, so the biggest thing you need to remember is the difference between scale factor and ratio. Okay, let's take a look at this next type of dilation. Okay, so we're gonna be able to figure out the scale factor and the ratio for this figure to the right. Now this one's different. The pre-image is actually the larger one. So I'm gonna highlight this in blue. So that is my pre-image. And then my image, my new one, is highlighted in pink now. So it got smaller, okay? So we're gonna say this dilation is a reduction. So therefore, the scale factor is going to be it's going to be greater than 0, but less than 1. Okay, so let me flip back on this one here. This one was an enlargement, and therefore this one is greater than 1, like here. So now it's going to be less than 1, but we still need it to be greater than 0. So let's do the ratio first, because the ratio is a little bit easier. You always want to go from pre-image to image. So I'm going to highlight some corresponding sides that are given, which this 7 corresponds to the 2, because that's on the left side, and then over here on the left side. So from 7 to 2, that's what our ratio is going to be, 7 to 2. And you can't simplify that anymore, so we're going to just leave it like that. Now the scale factor, remember, needs to be less than 1. Okay, so a lot of people probably want to say this right here. Well, if you do this fraction here, that is the number greater than 1. That's actually 3.5. Okay, so that is not our scale factor. Our scale factor is actually going to be, and the easiest way to write this is to use the 7 and the 2, except instead of putting 7 over 2, it's going to be 2/7. And that number right there is less than 1, okay? I would not turn it into a decimal, although if you did, it wouldn't be wrong, but I would just leave it as this right here. So the scale factor is 2/7. So all of the sides are getting 2/7 smaller. And I know it's not a pretty fraction, but it is what it is, because these are nice whole numbers, but the fraction of the scale factor is not too friendly, and that's okay. So now in order to figure out t, here's where you want to kind of use that proportion that we had talked about. And again, you did this in middle school. So the easiest proportion to write down is, we can say 7 is to 2 as 5 is to t. We're going to solve for t. And so now we're just going to cross multiply. So 2 times 5 is 10. 7 times t is 7t. Divide by 7, that cancels. So t is actually 10 over 7. And if you want to write it as a mixed fraction, that would be 1 3/7. If you want to put it as a decimal, you can also. Okay, so those are your 2 types of dilations. It's either going to get larger or it's going to get smaller, okay? And whenever you dilate something, the figures are similar. So let's just try some examples with these similar figures. So it says triangle XYZ is mapped onto X prime, Y prime, Z prime. So whenever you see that, guys, the letters, if they're just regular, that's going to be your pre-image. Okay, so you may want to label that. Whenever it has these little apostrophes here, that's going to be the image. Okay, so remember the pre-image is the original, the image is the new one. So it says find the scale factor, state what type of dilation it is, and then find some missing side links. Okay, so they actually gave us some information here, so we want to go ahead and plug that in. So they gave us x, y is 3, so we're just going to label. X prime, y prime is 7.5. So let's label that 7.5. XZ is 9. And YZ is 7. Okay, so they gave us all 3 sides over here. We don't know all of these. So since this is our pre-image and this is our image, you should know that it's going to be an enlargement. Okay, so our scale factor is greater than 1. Okay, so this is getting larger, okay, or bigger. So what is our scale factor? How many times bigger did it get? Okay, so it went from 3 to 7.5. So 3 to 7.5. I know those aren't such pretty numbers, but the way you can easily figure that out is divide and see how many times 3 goes into 7.5. So let's get our calculator if you don't know that. 7.5 divided by the 3, so 2.5. So our scale factor is 2.5. And remember, since it's getting bigger, that's what we want our scale factor to be, larger than 1. Okay, now the ratio, remember the ratio goes from pre-image to image. And so I'm going to highlight those numbers again, 3 to 7.5. Okay, so then that's how we're going to write our ratio, 3 to 7.5. Now some people are probably thinking, well, can I write it as 1 to 2.5? Yes, you can. Okay, there's actually a couple of different ways you can write that. All right. You could also do without using the decimal here. You could say what this would probably reduce to is 2 to 5. You see that? This is probably a real nice ratio to use. Okay, but you would still get it right if you just use that. Okay, and technically you're really not supposed to have decimals, so this is the best one here. All right, so 2 to 5, which again comes from all of these are equal ratios. All right, so now to figure out y prime, z prime, we want to go ahead and set up a proportion. So to figure out this one over here, again, I'm going to use my main one. So 3 is to 7.5 as, if we're trying to solve for this one, y prime, z prime, let's use some color here. That's this side over here. That one is corresponding with this one here. See that? So we're going to say 7 is to y prime, z prime. Does everybody see how that is set up? So now we're going to cross multiply. What is 7 times 7.5? 52.5. And that is equal to 3 y prime, z prime. Divide by 3. Divide by 3. So this is going to be 17.5 units long. So 17.5. Okay, and it's okay that we have decimals. Let's try this one over here. So again, I'm going to still use my same ratio. 3 is to 7.5 as, so which one corresponds to that? So XZ is corresponding to this one. So as 9 is to x prime z prime. All right, so let's cross multiply. 9 times 7.5 is 67.5 equals 3x times z prime. Divide both sides by 3. Divided by 3 in the calculator. So this one is 22.5. Okay, so you're using these proportions to solve for those side links. Okay, and so remember also the difference between these two right here. These are very two different things, the ratio versus a scale factor. All right, let's try it again. Let's look at these two similar figures. It says this figure is similar to this figure over here. And so what is the scale factor? So first things first, is it getting bigger or is it getting smaller? That'll help you determine the scale factor. And if we're going from this one to this one, always double check with the numbers, it is getting smaller. So that means our scale factor, guys, needs to be less than 1, okay? So now we need to make sure what corresponds to what. So I'm gonna get my highlighter. So I have this 6, okay, which is EH, EH. Well, those are supposed to correspond to the first two letters, or no, I'm sorry, to the same letters in the same position. So AD, so where's AD? This one here. Okay, so those two correspond. Now, another great strategy is to redraw the figure so that it kind of matches up with it. Okay, so like this one here, I would redraw it to make it look like this. Okay, and so then we have D corresponds to H, A corresponds to E. See how I'm just going in the same pattern, D to H, A to E. C corresponds to G. And lastly, B corresponds to F. And this one that they gave me was 6 right here. Okay, so let me get my yellow highlighter so you can kind of see. So this one corresponds to this one. 8 corresponds to the 6. So if the 8 corresponds to the 6, how do you find the scale factor? Okay, well, you do not want to put 8 over 6 because that number is bigger than 1. 6 goes into 8 1 and 1/3 times. So that's bigger than 1. So that is not our scale factor. So our scale factor is actually 6 over 8, which reduces to 3/4. That is our scale factor. 0.75 is another way to write that, okay? So our scale factor is that. Now let's look at our ratio. Remember, our ratio goes from the original to the new one. So since it says it's going from A, B, C, D to E, F, G, H, it's getting smaller. So we're going to say 8 to 6, which we definitely want to reduce that. So it's going to be 4 to 3. You see how the ratio is different, but kind of similar to the scale factor, okay? 4 to 3 is different from 3/4, okay? All right, so we're just going to use that to solve for some sides. So what would EF be? Okay, so EF is right here, which corresponds to the 20. Sometimes you can do that in your head, sometimes you can't. So you can say 8 is to 6 as 20 is to EF. So 6 times 20 is 120, divided by 8 is 15. So EF is 15. And then it's asking for FG, which is this one here. So I'm going to do 8 is to 6 as, and this one corresponds to 12. So see, when you redraw it, it's easier to see how they're all in this kind of same corresponding position, as 12 is to FG. 6 times 12 is 72, divided by the 8 That's 9. So FG is 9. Angle F. Okay, angle F. So here's angle F. You have to ask yourself, what does angle F correspond to? Well, F is the second letter, so that corresponds to B. See how I'm using the way they wrote it out? This is very similar to what we did last semester about writing congruent polygons. They all correspond in the same order. So F is the same as B. Do we know angle B? We sure do. So guess what the measure of angle F is? 95. That was one of the things we talked about. Similar figures have the same exact angle measures correspondingly. Okay, let's look at H. Where's H? H is right here, and I don't know why I'm using this one over here. H is right here. It's better to use this one. H is going to be 80 degrees. Okay, going back over here, what were they asking? They were asking for F, right? So it's good to color coordinate. There we go. So see how this is easier to see. I shouldn't even be using this one over here. Should be using this since I redrew it and it makes life easier. All right, ratio of the perimeter of ABCD to the perimeter of EFGH. Well, if the ratio of the side is 8 to 6 or 4 to 3, well, if you're going to add them all up, it's still going to reduce to the same. So guess what? The perimeter is the same exact ratio because you're not multiplying the values by anything. It's the same thing. It's the side lengths. So therefore, what would be the perimeter of the new one? Okay, well, what's the perimeter of the original one? So that would be one thing that you could find. So the perimeter of ABCD is, and just add them all up, 45 plus another 20 is 65. Okay, so if the perimeter of the little one is 65, instead of finding every single side, which I know we already found 2, and I would just need to find one more, but I want to show you how to use the ratio and proportion to do the perimeter. So remember the perimeter ratio is 4 to 3, or you could use 8 to 6, it's the same thing. So you could say 4 is to 3 as 65 is to, and we'll use P for perimeter. And that's it. You just have to cross multiply. See, I'm using the ratio and I'm making a proportion so I can cross multiply. 65 times 3 is 195 divided by the 4. 48.75 is going to be the perimeter of the smaller one. All right. Okay, so that's working with corresponding parts of similar figures. All right, last page. Just to kind of fresh up on cross multiplication just one more time, I'm going to cross multiply here. First, 6 times x is 6x. You want to write your equal sign and then cross multiply over here, which you can either do this in your head or include this step. 4 times 20 minus x. Make sure you use the parentheses. Some people can distribute before they even write this step down, and that's fine too. So now I'm going to distribute. That's going to be 80 minus 4x. And then the rest is just algebra. So I'm going to add 4x to both sides to get rid of that. I get 10x on the left. I still have 80 on the right. Divide by the 10. And so x is going to equal 8. Okay, so you'll have a couple of those on your homework. And lastly, another ratio proportion problem. It says the ratio of seniors to juniors in the math club is 2 to 3. If there's 21 juniors, how many juniors and seniors are in the club altogether? Okay, so we want to set up a ratio and a proportion. So 2 to 3. Okay, remember that's another way to write this ratio right here. And so remember, think about how they said it over here, the seniors to juniors. So this is seniors to juniors. Seniors is on top. They said there's 21 juniors, so I need to place that on the bottom, just as I've done so here. And then I'm going to solve for x, which is going to be my seniors. So let's cross multiply. 2 times 21. 2 times 21 is 42. And then divided by 3, 14. So X, which is the seniors, is 14. So there's 14 seniors. So they were asking all together, so we just have to make sure we add. So 14 seniors, 21 juniors gives me 35 all together. Okay, so setting up a ratio and proportion, that's it. All right,